So we are still looking at the relationship between refractive indices. Don't forget, number one, we had looked at this derivation that this one here equal to 1 out of 2 into n2. Then let's look at another relationship where we are going now to say, consider a ray AO refracted from medium 1 to 2 and finally to 3 with a parallel boundaries as shown below. So that if we are having rays, we're going to consider ray AO if it is something like this, something like that. I can say this is the ray I'm talking about, and then refracted in this direction here. So this can be my, I can get there maybe some other good red pen. Can give me a red pen there. I can use a better one to distinguish these values. I can call this one, if this is media 1, this one 2, this one 3, I can call this one I1, and then this one will be R2. The same angle here will be also R2 because it's alternating. And then this will be equaling to now R3. Okay? I can call this one I1 in first media, and then it will give us angle of refraction R2, and then this one also will be, or I can even call this one I2 as a result of that, and then this one I3. Is that okay? So this is our medium. You can name it medium that, medium 3. So this is O, this is A, the ray is moving in this direction there, and then B, like that. So we are supposed to get another expression for our derivation if this OA from medium 1 went to 2 and then came finally to 3. So we are now going to say, we shall say for medium 1 to medium 2, we shall say refractive index from 1 to 2. If it is traveling from 1 to 2, it will be equaling to sine of the angle in 1, which is I1 divided by angle in the second one, which is I2. This is the angle of incidence in the second one, but it is equaling to this one. That's why I'm calling this one I2. But even if you can call it R, but put in your mind that this angle is supposed to be the same as that. So I can call this one here equation 1. And then I can also say for medium 2 to medium 3, that if it is now moving from 2 to 3, I can say that its refractive index of 2 going to 3 is the same as from 2 to 3. That means I'm looking at this point here. It will be sine of I2 over sine of I3. And this is my equation 2. Okay? So I will say that equation 1 times equation 2. This one will give me refractive index of 1 to 2 times 2 to 3 equaling to sine I 1 out of sine I2, which is equaling to sine I2 divided by sine I3. You realize that this is refractive index from 1 to 2 and then from 2 to 3 equaling to sine I1 out of sine I3. Okay? But we are aware that the sine I1 to sine I3 is telling us that we are looking at refractive index of 1 with respect to 3. So therefore we can conclude that from 1 to 2 and then from 2 to 3 is the same as from 1 directly to 3. This is also another relationship that can help us in addition to what we actually looked at behind there. So now let's meet next and now look at the last relationship related also to when we're trying to relate also the refractive indices of different mediums.